Hello students, welcome to this lecture. So in this video we are going to discuss about the memory devices and their selection for given embedded systems. So memory devices are main parts in case of an embedded system. It can also be extended towards small or medium or large scale embedded systems too. So depending upon the memory requirements, we need to select what kind of memories we actually want to incorporate in those embedded systems. That topic that we are going to discuss in this particular video. So memory devices can be broadly classified into two types. One is ROM, that is read-only memory. Another one is RAM, that is random access memory. So from the name itself we can come to know that the read-only memories are going to be the program memories where we once we program means we should not change those programs. So for those purposes we will be using read-only memories. Random access memories will be mainly used for data storage purposes. So for the data storage purposes and for dynamic data or the non-static data can be stored inside the RAM memories. So we can eventually we can subclassify these ROM and RAM as follows. So for the ROM we will be having PROM and OTP ROM, EEPROM, E2PROM and flash devices. So PROM means it is a programmable ROM. So once the ROM devices are going to be manufactured, once they are being programmed, we cannot change them afterwards. So whatever the programs we want to use in an embedded system as an non-changeable, those kind of programs can be used with the help of PROMs. And for OTP ROM and all, whenever we are having embedded system, the design of the embedded system is fixed means for those embedded systems, the initialization programs and the startup and the specialization programs can be programmed in an OTP, because OTP means it is a one-time programmable ROM. So using a one-time programmable ROM in an embedded system is meant to that those kind of programs cannot be changed at any cost of time. So the next is going to be EEPROM and the E2PROM. So we will be discussing those things in the next slides. So in case of RAM, we can classify the RAM into 8 different classifications. SRAM, that is going to be called as static RAM, dynamic RAM, that is going to be called as DRAM, NVRAM, that is going to be a non-volatile RAM, and EDO RAM, that is going to be extended as extended data output RAM, SDRAM, that is synchronized DRAM, and RDRAM, rhombus DRAM, PDRAM, that is going to be extended as parameterized distributed RAM, PBRAM, that is going to be extended as parameterized block RAM. So in this particular section we are going to see what are all the ROM devices, so how we can classify them, how we can differentiate them, and how we are going to use them for in embedded systems. And in final we will be seeing what is the selection of an embedded system with the help of some case studies. So first, the ROM devices normally manufactured at foundries using fabrication techniques called chip manufacturing or the chip evaluation softwares. So we will be that is the Tanner softwares. We will be programming those particular ROM devices into one foundries. So from those foundries, whatever the ROM devices we are getting, we can program them using the ROM images. So what do you mean by ROM image means? Whenever we are having our program to be executed, that program have to be converted into hexadecimal file, because hexadecimal file is an eventually on binary file. So we need to convert those programs which we are written in our high level languages. Those particular programs have to be converted with the help of tool chains. Tool chains means compilers, assemblers, linkers and locators. Using those tool chains, we will be converting an higher level language program into an binary program. So that binary program is compiled as one ROM image. So that ROM image file have to be ported into one ROM device, so that we can use that particular program in the software purposes. So normally a ROM device have R inputs and 8 outputs, because ROM devices and the most of the memory devices are working under the category of 8-bit data length. So those particular devices are going to be, since those devices are going to be working on 8-bit outputs, so we will be having R inputs and 8 output pins, so that 2 power R combination circuits to be designed. So ROM devices are going to be designed with an combination logic circuits, so that whatever the program we have compiled, those programs are converted into binary files. So those binary files are going to be converted into combination logic blocks. So those combination logic blocks are to be ported into one ROM images. So those kind of memories are going to be ROM or one-time programmable ROMs. So normally the data accessed in a ROM device is going to be by two modes. One is random access mode, another one is serial access mode. So we can use for some of the ROM devices can be returnable ROMs. So we can have write and read cycles. So read and write cycles are going to be equal in nature for ROM access mode, random access modes, and read and write cycles are not going to be equal. So there may be some disparities between read and write cycles in a serial access mode. So the serial access mode is going to be a very faster mode. So in those modes, the normal writing and the reading cycles are going to be actuated with the help of microprocessors. So the common data structures which we are going to use in the memory devices are based upon the memory requirements and the software requirements which we pose in our embedded systems. So normally the devices whichever we are going to use are very much need of two different segments. One is going to be in data segment, another one is going to be an instruction segment. So if it is in either case, we can also have some stack portions also, and we can have some heap portions also. So stack portion is for programming for programming the memory device for particular interrupt service blocks. So those particular segment is very much needed in an embedded system. So we will be having data segment, instruction segment, stack segment, and another one is heap segment. Heap segment is required in an embedded system where we have some mathematical calculations or some programmable calculations, so that the variables, the static or the dynamic variables are going to be stored inside a heap during the execution of the program. So for that we need to have some heap segment also. So these four kind of segments are very common in all the embedded systems. Apart from them, we may have some of the segments which are listed here: stack segment, table segment, queue segment, and array segment, list segment, and the hash table segment. So here the array, list, and hash tables are going to be coming under the main category of array data structures or list data structures. Queue and the table are going to be coming under the table data structure. So these kind of data structures are mainly used in kind of embedded systems. So the array cycles are eventually are going to be filling once in a specified locations wherever we need to erase the data. So in those particular elements or in those particular cells, if we fill with them once, so the array cycle will be finished. So that is going to be the array cycle essentially. EEPROM, it is an electronically programmable random access read-only memories. Electronically programmable read-only memories. So these kind of memories are going to be corrected by UV rays. So the arrays cycle are going to be done by UV rays, and erase and write cycles are going to be equal in nature, and eventually the EEPROM chips are going to be plus 12 volt in nature. And EEPROM, that is electronically erasable and programmable read-only memories, are going to be the chips wherever we have the array cycles of up to 1 million cycles. So and also the return cycles are also going to be 1 million cycles. So up to those particular amount of cycles we can use the EEPROM. So for the EEPROM, that is the some exposure to the UV radiation may be allowed. So but in the EEPROM we will be allowed only up to 1 million cycles of erase and the write cycles. And these kind of chips are going to be plus 5 volts in nature, and here the write cycles are going to be normally longer than the erase cycles. And for the flash drives, so the flash drives are operated with the help of the USB algorithms. So by using USBs, we are going to access those flash devices. Normally the flash devices are going to be programmed with the sectors in nature. So the data are stored in the form of sectors. So a sector can be varied from 256 bytes to 16 kilobytes. So we can extend these flash devices up to gigabytes also. So for those kind of very large memory storages are going to be designed with the use of flash devices. So also the flash devices are going to be operated with the plus 5 volt in nature. The applications of the memory devices are going to be the EEPROM are mainly going to be used with the program codes and interrupt service routines. Kernels, the kernels are going to be the main heart of the operating systems. So most of the operating systems are going to be stored inside an EEPROM because we need to update them whenever we need to do, and also the interrupt service routines and the program codes are going to be normally stored inside an EEPROM memory chips only. And then the initialization programs also. So for the embedded systems, whenever we need to restart and reallocate a particular embedded system, we need to have the initialization of the peripheral devices. So those kind of initialization programs can be stored inside a EEPROM memory chips. And if you use EEPROM memory chips, we actually do the storage of current date and time of one particular embedded systems, because for the current date and time we will be updating it once upon upon the updation of the clock. So upon the updation of the clock, whenever we need to have those particular type of memory devices, we need to have the EEPROM memory devices too only. So because the updation is going to be in seconds in nature, so for those nature of updation, we need to have EEPROM memory devices, and the current port status and the malfunction data of the embedded systems are going to be stored inside an EEPROM only. So the malfunction data are going to be stored in the form of log files, so we can retrieve them whenever we need. And flash devices are going to be used for storing media data from digital cameras and storing the compressed voice from the voice recorders. So you can eventually say the storing of media files in the flash devices. And the OTP RAM, that is the one-time programmable ROM, are going to be used with the smart cards, because in the smart cards we will be storing those consumer data, and the updation of the consumer data are going to be stored inside an smart cards only. So in the smart cards we may be having the account number or the consumer details of a particular customer, so we can retrieve them whenever we need. So those kind of details are going to be one-time programmable, so we can use these kind of one-time programmable ROMs in the smart cards and the booting programs, because for an embedded system which needs to have a bootable drives and bootable operating systems, we need to have bootable programs. So those bootable programs are going to be very much essential for those particular embedded systems where we need hard disks, because the hard disk and all going to be operating under either electronically or magnetically. So we need to have those boot programs to start up the starting of the operating system functions and also the initialization programs. So for that we need to have one-time programmable ROMs and the ATM cards. So as I have said about this smart cards, the same purpose only we will be using the ATM cards. So for those purpose, OTP ROMs are going to be suitable application. So now we can discuss about the RAM chips. So in RAM chips we will have SRAM. SRAM is a static RAM. So RAM devices which uses the flip-flops to store data. So the data is lost when power is cut off. So since we are going to use the flip-flops for the SRAM, so whenever the power is cut off, the data will be lost. So also these SRAM are going to be costly in nature, so it is used in caches only. So no need to refresh it frequently, because DRAM, that is the another one counterpart of this particular SRAM, is going to be the DRAM. So in those DRAMs we will be using mass capacitors and transistors for the data storage. So for those particular RAM devices we need to have the frequent refreshing of the data, because the frequent refresh is needed, that because the mass capacitors are leaky in nature. So the frequent refresh is needed, because long-term storage is somewhat difficult in case of mass capacitors. And the data remnants. So data remnants is going to be a very important concept, that data remains intact when even when the deletion of the data is commanded, because whenever we are going to delete an data from a particular disk, if you give the deletion command also, that the data cannot be deleted at fully, because if you give the permanent deletion only, they are going to be deleted. So that kind of property of the SRAM devices are going to be data remnants. So this the permanent deletion manipulation of any data is being done only with the help of operating system only. So that kind of practice is going to be only possible when in case of using the operating systems only. So the DRAM, the RAM devices where the data are stored in an array of mass capacitors and the transistors arrangement. In those arrangements, the rows are going to be called as word line and the columns are going to be called as bit lines. In those devices we will be having some sense amplifiers. So these sense amplifiers are going to be used to recharge the setup while reading, because the reading operation may discharge some of the amount of charges which leads to a disturbance errors. Because whenever we are frequently reading particular data from the DRAM, those charges are going to be drained at some point. So we need to recharge them frequently. So those recharge purpose is being met out by this sense amplifiers. So these kind of DRAMs are going to be used in the computer main memories and the networking memories. And also these DRAM are going to be accessed in asynchronous nature only, and the DRAMs are required to refresh at every 64 milliseconds, and the data remains can also be maintained in these kind of memory chips. And NVRAM is going to be a non-volatile SRAMs, because SRAMs are going to be costly, and this kind of SRAMs are volatile actually in nature. So but this NVRAM are going to be non-volatile in nature, so that we can whenever the power is also cut off, this kind of particle devices cannot be erased. So normally SRAM, for this reason only, these kind of devices are going to be used in networking, aerospace and the medical fields, and also in military applications also we can use this NVRAM devices. And SDRAM are going to be a very important memory devices in case of large and very sophisticated embedded systems. This can be operated as synchronous dynamic random access memories. So here we have two types. One is going to be a single data rate and another one is going to be double data rate. So double data rate is nowadays they are going to be very much common in the laptops and the current PCs. The controller works as a finite machine, so SDRAM controllers are going to be working as a finite state machine with the pipelining capabilities, because if you use the pipelining capabilities, then the consequence fetching of the data are possible, so that we may have those kind of particular devices can be very fast in nature. So very fast data fetching due to the presence of the pipelining is possible. So we can achieve up to 1 GHz speed of data fetching. The data words fetch at the intervals of 6 to 12 nanoseconds. So that next data word would be ready when the previous data is ready. So example for this kind of SDRAM are going to be Samsung KM48SL 2000, the first SDRAM chip. And this kind of SDRAM devices having very low latencies. Latency means the time period between giving the command and the actual reaching of the particular data. So the delay between the given command and the actual data reach is going to be called as latency. Whenever we are going to design an embedded system, we need to have very low latencies only. So for those kind of systems where we need to have very fast kind of data processing, we need to use these kind of SDRAM devices. And very low waiting states also is possible in case of SDRAMs. And RDRAMs are going to be company specific, because Rambus is a company which design this kind of RAMs, so that in their name only they are supplying this particular DRAM chips. So Rambus DRAMs manufactured by the Rambus company, and it operates at 800 megahertz, and they are the first devices where we are being introduced with burst mode operations. So burst mode operation means we can transfer the data from the memory devices in bulk. At one clock cycle, we can transfer up to 10 megabytes of data too. So those kind of very large data sets can be transfer from this kind of RDRAM devices. So here we are using actually the steady sequence pipelining technology. So using this technology, it may be allowed that 16-bit data transfers at the rising edge of the clocks, and the same as that of falling edges also. So in consolidated form, we can use 32 data transfers in a single clock cycle. And PDRAM and PBRAM are going to be parameterized data RAMs and the block RAMs. So these are all for dedicated purposes, because whenever we are having multi block of data, so we need to have those kind of buffers for each and every communication lines or each and every devices we are using. So the dedicated blocks for each and every external devices we are connected, and the input output buffers too. So and the transceiver subunits also. So for those, the memory is being allocated as slices in the RAM, and these kind of RAMs are patented ones. So Xilinx have patented these kind of RAMs, and this can be configured as 16x1 RAMs, and 16 lookup tables can be programmed here, and also 16-bit shift registers can be used in this particular PDRAMs and PBRAMs. So here we have given a case study about the selection of the memory devices. Since we have discussed these kind of case studies in the selection of the processors also, so the same case studies is going to be discussed here too. First case is going to be chocolate vending machine, and the second case is going to be data acquisition system. Third case is going to be network transceiver. Fourth case is going to be video processor. So processes that we have discussed, so I don't need to explain it again. Under the ROMs, we can use the very low ROM rate for this particular chocolate vending machine from 4 KB to 8 KB, and the 8 KB is necessary for data acquisition systems, but the ROM devices are not required in case of video processing in the network transceivers. And EEPROMs has been given, it is from 256 bytes to 512 bytes, and the internal RAM are going to be 256 bytes to 512 bytes, those for chocolate vending machine and for data acquisition also. And we need to require the parameterized distributed RAM and the parameterized block RAMs for these kind of applications where we need to have this particular voice processor and the network transceivers. Thank you.